Hello, welcome to Samarpit Academy. Today in this video, we will be discussing one very important chapter of class 10th, which is reflection of light at curved surfaces. Now, before starting this video, let me tell you one thing. There is a branch of physics called as optics. Now, reflection of light at curved surfaces, refraction, human and colorful world, all these particular chapters which you might be seeing in class 10th fall under this branch called as optics. Now, if you look at previous year papers of class 10, be it of any board, Andhra, Telangana, CBSE, any board, you will see a good number of questions comes from this particular chapter. That means comes from this particular branch of physics called as optics. So optics is very, very important. Now, remember, this particular chapter is not only important for class 10, it is equally important for other classes wherever this chapter is included. And also, one very important point is when you go into higher classes, for example, class 12th, optics is one of the most important chapter. If you take any competitive examination, you will see a good number of questions are being asked from this particular branch of physics called as optics. So in this video, what we will be going to do is we will be discussing important formula in this as far as this chapter is concerned. Now, this video is not a detailed discussion of each and every concept. So this video is a kind of quick revision of the important formulas and concepts. So without any delay, let's start this video. Now, you all know that, for example, if I take a plane mirror, so let me take a plane mirror. So this is a plane mirror. So it will have two surfaces. One is rough surface, another one is smooth surface. Now, when I sent a light towards a plane mirror, so I have sent a light like this. So what happens is after the light hits the plane mirror, it will bounce back. So the phenomena of bouncing back of light after hitting a smooth surface is called as reflection of light. So you can see this particular light ray which is going towards the mirror, which is trying to hit the mirror. So this particular light ray is called as incident ray. And the ray which bounced back, the ray which came back after hitting the mirror is called as reflected ray. And the point where the light ray hit the mirror, that is called as point of incidence. So this is point of incidence. Now what you have to do is, you just draw a perpendicular line at point of incidence to the mirror. That means draw a perpendicular to the mirror surface at the point of incidence. So let me draw this line for you. So this particular line is called as normal line. Now you can see some angles here. One is the angle between incident and normal, which is called as angle of incidence. Second is the angle between reflected and normal, which is called as angle of reflection. Third is angle between incident ray and mirror surface, called as glancing angle. Remember, if this is G, this will also be G. So what is angle of incidence? It is the angle between incident ray and normal line. What is angle of reflection? It is the angle between reflected ray and normal line. What is glancing angle? It is the angle the incident ray or the reflected ray making with the mirror surface. Now there are two important laws of reflection. Listen carefully. What is the first one? The first one says that the incident ray, normal line and reflected ray. So what are the three things? Incident ray, normal line and reflected ray all lie in a single plane or all lie in a same plane. That means all these three, incident ray, normal line and reflected ray, will be confined to a single plane. For example, in this context, they are confined to the plane of the board. This is the first important law of reflection. The second is, here you can see two angles. One is angle of incidence, other one is angle of reflection. The second law says that angle of incidence is equal to angle of reflection. So I is equal to R. So if the angle of incidence is 30 degree, angle of reflection will be 30 degree. Now see here, I have said that normal is basically perpendicular to the mirror surface. So this angle here is 90. So what I can say is I plus G is equal to 90. So from this, what is G? G is 90 minus I. Since I is equal to R, G can also be written as 90 minus R. So G is called as glancing angle. Now, see here. So what the mirror which I have taken here is basically a plane mirror. So what is a plane mirror? Plane mirror is basically a mirror whose reflecting surface is plane, whose reflecting surface is flat. And mirror can be plane or mirror can be spherical. Remember, the two laws which I have told you just now, the laws of reflection, is valid anywhere the reflection is happening. The reflection may happen on a smooth surface, the reflection may happen on a rough surface, the reflection may be happening on a plane mirror, the reflection may be happening on a spherical mirror. Wherever the reflection of light happens, remember the laws just now I have told you are valid. Now, see here, mirrors, they can be two types. One is plane mirror, is basically a mirror whose reflecting surface is plane. Second one is spherical mirror. What is a spherical mirror? It is basically a mirror whose reflecting surface is spherical. Now, no need to tell about plane mirror. Now, in spherical mirrors, there are further, it is divided into two types. One is concave, other one is convex. What is concave mirror? Basically, concave mirror is a mirror whose reflecting surface is, basically, see here, first thing is, spherical mirrors are those mirrors whose reflecting surface is curved. Among them, there are two types. One is concave, other one is convex. So what is concave? Concave mirror is basically a mirror whose reflecting surface is curved inwards. So here is the reflecting surface of the concave mirror. So concave mirror is basically a spherical mirror whose reflecting surface is curved inwards. Now what about convex? It is opposite of concave. So this is a convex mirror. So here you can see the reflecting surface is curved outwards. So convex mirror is a spherical mirror whose reflecting surface is curved outwards. So these are the two varieties of spherical mirrors. One is concave, other one is convex. So we will be discussing about them, concave and convex. But before that, so let me first discuss about a slight discussion about plane mirror. Now see here, so if I take a plane mirror, in front of it that I will keep an object. Inside the mirror, there will be an image. Now let me discuss some properties of image formed in a plane mirror. First thing is, when you stand in front of a plane mirror and if you see your image, the mirror is basically formed behind the mirror. So the image which is formed in a plane mirror, you cannot see that image on a screen. You have to see that image in the mirror itself. See, such an image is called as virtual image. So the image formed in a plane mirror, remember, it is a virtual image. This is the first point. Second point, see, this is the plane mirror. So from object to mirror, you measure the distance. That is called as object distance. And from object to mirror, you measure the distance. The distance is called as object distance. Again, from mirror to image, you measure the distance. That distance is called as image distance. Now what happens is, in a plane mirror, the value of object distance is equal to the value of image distance. That means if object distance is 30, image distance will also be 30. That means if we keep an object in front of a plane mirror, let's say 20 centimeter, the image will also be formed at 20 centimeters behind the mirror. The third point about the property of image in a plane mirror is, whatever be the object height, the image height will also be the same. So object height is equal to image height. That means there is no magnification as such when a plane mirror is concerned. That means the object and image, their heights will remain same. So there is no enlargement, there is no diminish, or there is no decrease of height as such. So the object height and image height remain same. So we can say that the magnification is 1. The value of magnification as far as plane mirror is concerned is 1. So I will talk about magnification in a short while when I talk about spherical mirrors. But remember, the magnification value is 1. This is third important point. The fourth point is, see here, in a plane mirror, the upside is coinciding with the upside. So like this, upside is coinciding with upside. So such type of images are called as, remember, they are called as erect images. So we can say that the image formed in a plane mirror is erect image. So upside is coinciding with upside. What is the opposite of erect? Inverted. So inverted images can also be formed. I will be talking about that. But as far as plane mirror is concerned, remember the image is erect. This is the fourth important point. One last but very important point about the property of image in plane mirror is image is laterally inverted. The image is laterally inverted. That means if you stand in front of a plane mirror and raise your right hand, the image appears to raise the left hand. That means left will become right, right will become left. So this particular phenomena of plane mirror, where left becoming right and right becoming left, is called as lateral inversion. So these are the important properties of images formed in a plane mirror. Now, I have told you that if you take a plane mirror and you stand in front of a plane mirror, the image which is formed is virtual image. Now, images, remember, can be two types. One is virtual, the other one is real. So what is a real image? What is a virtual image? Just I have told you that the image which is formed in a plane mirror is virtual because we cannot see that image on a screen. So remember, virtual image, the first important point is cannot be obtained on a screen. Now what about real image? It can be obtained on a screen. That means you can see this image on a screen. This is the first important difference between real image and virtual image. The second important point about real image and virtual image is, see here, when light hits a particular mirror, the reflected rays will meet. That means if you take a real image, what happens is, I am calling this image as real image. That means the reflected rays are actually meeting. That means when light hits a particular mirror, and if the reflected rays after reflection actually meeting, then that image where the image that is formed is basically a real image. So what happens in a real image is the reflected rays after reflection. So here what happens is the reflected rays actually meet at some point. So here the reflected rays actually meet. And what about here? Here reflected rays appear to meet. That means they are not actually meeting. So, but they will give that means there is a false impression that they are meeting, but no, they are not actually meeting. But they appear to meet. And I just have told you that virtual image, that means the image which is formed in a plane mirror, is basically a virtual image. I have said that it is an erect image. That means upside will coincide with upside. So like this. But remember, as far as the real image is concerned, the upside does not coincide with the upside. The image is basically inverted. So this is how an inverted image looks. So let me tell you these differences by showing you the image. That means I will show you the differences between the real image and virtual image using the ray diagram. Now see, basically in plane mirror there is no scope of forming a real image. That I have already cleared. Now see here, you can see this particular mirror which is over here is a spherical mirror. And to be very specific, it is a concave mirror because the reflecting surface is curved inwards. Now see here, this is the object and here is the image. Now see, the image which is formed here, I can keep a screen over here and I can see that image on a screen. Screen means I can put a paper or I can put a white screen. So this image is able to form on a screen. So this is a real image. So what is the first point? First point I have said that real image is a image basically which is formed on a screen. Now second point, you can see that these are the reflected rays. They are actually meeting at that point. So you can see the reflected rays after reflection from the mirror are actually meeting. So that's where the name comes, real image. This is the second point. Third point, you can see the object is like this, but whereas the image is downwards. So upside is not coinciding with upside. So that is real image is inverted image. I think these three important characteristics of real image, I think you have got the idea. Now let us look at virtual image. Now see here. So this is an object here and see here this is the image. Virtual image is formed behind the mirror. That means there is no scope of seeing this image on a screen because this is inside the mirror. So What is the first point about virtual image? It cannot be obtained on the screen. Second important point you can see here, these are the reflected rays. Are they meeting? They are not meeting here. No scope of meeting here. That means the reflected rays are not actually meeting. But if I extend them backwards, they appears to meet here. So what is the second important point about virtual image? The reflected rays after reflection from the mirror appears to meet at some point. And what is the third important What is the third important point about virtual image is, you can see here, so this is the object and this is the image. So upside is coinciding. So like this. So that means the image is erect. So these are the differences between real images and virtual images. So I think with the help of a diagram, I am able to show all these differences. So you have to be very careful in knowing minute details of the differences between real image and virtual image, because many times this question is being asked. And you have to cite an example also. For example, virtual image, generally our image which is formed in a plane mirror is a virtual image. An image formed by a distant object on a screen by a concave mirror is basically a real image. So these are the differences between real image and virtual image. So I have already told you about spherical mirrors. Basically, they are those mirrors whose reflecting surface is curved. Now let me introduce some terminology about spherical mirrors. So let me first take a spherical mirror. So this is a spherical mirror. So this particular mirror will have a midpoint. So I call this midpoint as pole. So what is the midpoint of this mirror? Pole. Now see here, this mirror is basically, you can think this mirror as part of a sphere or part of a circle. So if this mirror is part of a sphere, it will have a center. So that center is called as center of curvature. So what is P? Pole. What is C? Center of curvature. Now you pass an imaginary line between C and P. This is called as principal axis. What we call this? This is principal axis. Now there is a point C, center of curvature. There is another point P, pole. That imaginary line which is passing through these 2 points, we call it as principal axis. Now there will be some midpoint for P and C. So let that midpoint be F here. Remember, this F is called as focus. So P, pole, F focus, and C center of curvature. Now what you have to do is find the distance from pole to focus. This particular distance is called as focal length. And again find the distance from pole to center of curvature. This particular distance is called as radius of curvature. So what is focal length? It is the distance from pole to focus. What is the radius of curvature? It is the distance from pole to center of curvature. So there is a relation which you have to remember, the relation between R and F, because I have already told that F is midpoint of P and C. So the relation is R, radius of curvature, is 2 times focal length, or this can be written as focal length is equal to radius of curvature by 2. This is the important relation. So these are some important terminology about spherical mirrors. Now see here, one very important concept, or one very important topic as far as reflection of light at spherical surface is concerned, is ray diagrams. So there are 6 ray diagrams for concave mirror, and there are 2 ray diagrams for convex mirror. So what is a ray diagram basically? See here, if you take any mirror, you will place an object in front of that mirror. Depending on the object location, an image will be formed. That image will have certain size. That image will have certain characteristics depending upon the object location. So if you change the object location, the image size can change, the image characteristics can change. So if you depict them using diagrams, those diagrams are called as ray diagrams. So let me now discuss about ray diagrams. Now you can see here, this is basically a table which summarizes the size, the position of image, and the nature of image depending upon the object position. So you can see here, this is the position of object, this is the position of image, this is the size of image, and this is the nature of image. So you will have 6 ray diagrams as far as concave mirror is concerned. Now let us look each of this diagram. Now first diagram you can see here. So one important point you notice here, see here, I have kept the object at infinity. From infinity a parallel beam has come. It has hit the mirror. This mirror is concave mirror. And all these rays are meeting at a particular point. I have told that this particular point is called as focus. So what is focus basically? When a parallel beam hits a concave mirror, after reflection, the reflected rays will meet at a point. That point is called as focus. So what is concave mirror basically doing with a parallel beam? It is basically converging the light rays. It is basically, that means focusing all the light rays at a single point. That's why remember, concave mirror, let me write that, concave mirror is called as converging mirror. So why the name converging? Because it is able to converge all the light rays at a single point. So you can see here first diagram, where is the object position at infinity, where is the image position at the focus, how is the image point sized, and where is the image from left side or right side? Left side. That means I can see it on a screen. So this image is real image, and real image you already know it is inverted. Now second position you can see. Now I kept the object beyond C, just beyond the C. So this is the object. Where is the image formed? Between C and F. C and F. And you can see image has diminished. So you can see the height of object is more compared to the height of image. So image is diminished. And you can see this image is formed on the left side. I can able to catch this image on the screen. So this is a real image and an inverted image. Now third diagram you can see I have kept the object at C. Image is also at C. And you can see object height and image height is same. So that means the object height and image height means same, means the image is same size as object. And again the image is forming on the left side. So I am able to catch this image on the screen. So it is a real and inverted image. Next, you can see I have kept the object between C and F. So when I kept the object between C and F, image is forming beyond C. And you can see the object here is, object height is small, whereas the image height is very big. So I can see that the image has enlarged. Again, this is the real image and inverted image. So you can see that I am moving closer to the pole. So now I have kept the object here between C and F. Now next you can say I have kept the object exactly at F. So when I kept the object at F, image is formed at infinity. So since it is forming at infinity, the image will be highly enlarged. And since it is forming on the left side, I am able to catch that image on the screen. So it is real image and inverted image. Now you can see that in concave mirror, there are 6 ray diagrams. Only in one case, virtual image is formed. So what is that case? You can see when the object is placed between F and P. That means only when you place the object between focus and pole of a concave mirror, you can see the image is formed behind the mirror. So here is this is the only case where the virtual image is formed. So you can see this is the object height and this is the image height. So image height is more. So image is erect, image is enlarged, and image is virtual. So these are the 6 ray diagrams as far as concave mirror is concerned. Now you should also remember some uses of concave mirror. Remember, concave mirror is basically a converging mirror. So I can use this mirror to focus light rays at a single point. So I can use this in a solar panel to focus the light ray at a particular point. And you can see here, when I kept the object, see the diagram here, once again this particular diagram. When I kept the object between pole and focus, you can see I have got a virtual erect and enlarged image. So I can use this mirror as shaving mirror to see an enlarged image of a face. Or this mirror can be used by dentist to see the enlarged image of teeth or some parts of it. And you can also see that this, you can see when I kept the object at infinity, image is formed at focus. And when I kept the object at focus, image is formed at infinity. So due to this property, this particular concave mirror is also used in headlights and searchlights. So that is in a headlight or searchlight, at the back I will keep the concave mirror, at the focus I will keep the light. So from focus, light will come and I will get a parallel beam. So that's how this mirror can be used in various situations. Now let us look about convex mirror. So I've taken a convex mirror, so you can see convex mirror. Convex mirror is basically a mirror whose reflecting surface is curved outwards. So I kept the object at infinity. So rays are coming, but you can see the rays are being diverged. So I can say that convex mirror is basically a diverging mirror. It is basically which type of mirror? Diverging mirror. And whereas concave mirror is concerned, it is a converging mirror. So this is the first, that means the only two ray diagrams are there. So in first case, you can see object is at infinity, image is at the focus behind the mirror. You can see the image here. You can see it is highly diminished. Since it is forming inside the mirror, it is virtual image, and you know that virtual image is erect. Now see the second ray diagram. So I have kept the object close to the mirror. That means close to the pole of the mirror. So image, you can see it is forming between pole and focus. You can see the image is diminished, and since it is forming behind the mirror, it is a virtual and direct image. So you can see that as far as convex mirror is concerned, the images are always virtual and direct. You can see here the images are virtual and direct. So there is no chance of forming real image as far as this convex mirror is concerned. But there is one advantage of this mirror. See here, the first advantage is it is always forming a virtual and direct image. The second advantage is, as far as convex mirror is concerned, it will give a wider field of view. So generally in our vehicles, the mirror which we use to see the traffic is basically a convex mirror. So that's why convex mirror is also called as vehicle mirror. So why this is used in vehicles? Because it gives a wider field of view. And the image which is formed in that mirror is virtual and direct. So I can see a large chunk of area in a small mirror. So it is easy for driver to see the entire traffic behind him. So it is used in vehicles. Also in certain places like in shopping malls or in some stores. So they will basically place a convex mirror there. So they can see the entire view of the shop is visible in that mirror. Even in metros also. Or even where there is, that means wherever there are turns on road, they will basically keep this convex mirror, so that the driver or anyone who is driving the vehicle can see the entire view of that particular road or traffic. So this has got its own advantages. But remember, in this convex mirror, the images are virtual and erect. And what happens to the light rays is basically the light rays, if a parallel beam falls on this convex mirror, the light rays diverge. So that's where the name comes for this. It is a diverging mirror. So the ray diagrams, that is the 6 ray diagrams for concave mirror and 2 ray diagrams for convex mirror, the nature of these mirrors and the uses of these mirrors are very, very important for as far as examination point of view is concerned. Now, see here, you can see the diagram over here. So here there is a concave mirror. There can be a concave mirror, there can be a convex mirror. So in front of that I have put an object here. So this is basically object and this is basically image. So from object to pole, you measure this distance. This is called as object distance. And from image to pole, you measure this distance. This distance is called as image distance. So there is a beautiful relation which connects object distance, image distance, and focal length of the mirror. That relation is called as mirror formula. Mirror formula. So what is the mirror formula? Very simple. 1 by V plus 1 by U is equal to 1 by F. What is V here? Image distance. What is U here? Object distance. What is F here? Focal length. But remember, whenever you are using this mirror formula, we have to be very careful about the sign convention that we will follow. So in this image, you can see the sign convention. That means basically from this image, you can get an idea about the sign convention that you have to follow. Now see here. So this is pole. Basically, this is pole. You treat that pole as some origin. Now this particular horizontal line will be x-axis, and you can take a vertical line over here that will be basically y-axis. So this is origin. So this is basically positive plus x-axis. This side negative x-axis minus, and this is positive y-axis. This is negative y-axis. So let me rub all this. You can see here. See, this is object and this is image. From object, light will go like this. So see, whenever you are measuring anything, so what is object distance? From pole to object, this distance is called as object distance. And from pole to image, this distance is called as image distance. So whenever you are measuring any distance, remember, always distance are measured from pole. So from pole to, you have to go to object. Now the convention is, when you're, see, from the object, light is coming like this. So the convention is, whenever you're going in the direction of light, you take the measurement as positive, and whenever you're going against the direction of light, you take it as negative. Let me repeat again. Whenever you're taking any measurement in the direction of light, so you take it as positive, or when you're taking in the, that is in the opposite direction of light, you take that measurement as negative. Or to make things very, very simple for you, you can see here. See, basically object is on the left side. So this distance is basically negative. So object distance here is negative. And here image is also formed on the left side. So this image distance is also negative. But if image is formed here, somewhere here, suppose the virtual image, it is formed behind the mirror. So if the image is formed here, so then I have to measure image distance like this. So this is the image distance. That means I have to go in the direction of light. So then this is taken as positive. These are the important points about object distance and image distance. Now what about object height and image height? Now see, if the object is upwards, that means above x-axis, so object height is positive. If it is downwards, it is negative. That means if, for example, if I take a virtual image here, so virtual image is formed, that means you know that virtual image is erect. So if this is a virtual image, so the height of the virtual image is taken as positive. But this is a real image here. You can see the real image is inverted. So the height is basically taken as negative. So you have to be very careful as far as the sign convention is concerned. Now in mirror formula, there are three things. One is image distance, second one is object distance, other one is focal length. Now remember, as far as concave mirror is concerned, so concave, so for example, so let me do one thing, let me rub all this. So you can see here, what is this mirror? This mirror is basically concave mirror. So where is this focus? The focus is somewhere here. So it is on the left side. So the convention is, we take the focal length of concave mirror. So concave mirror's focal length, remember it is taken as negative. But if you have a convex mirror, its focus will be on the right side. So as far as the convex mirror is concerned, the focal length is taken as positive. So if you are having a concave mirror, the focal length is taken to be negative. And you are having a convex mirror, the focal length is taken to be positive. So all the sign conventions, you have to keep them in mind whenever you are solving the problems. So whenever you are using this mirror formula, you have to be very cautious about the sign convention. When you put, that means when you put V, U, F, the values of V, U and F with proper sign convention, then only you will be able to arrive at the right answer. Now let me introduce one last concept in this particular chapter, which is magnification. So I'm talking magnification here of that is magnification in terms of spherical mirrors. So magnification is denoted by symbol small m. What is magnification? Very simple. Height of image, hi, by height of object. Very simple. Magnification is height of image by height of object. Now I have already given mirror formula, which is 1 by B plus 1 by U is equal to 1 by F. Now as far as spherical mirrors is concerned, that means as far as spherical mirror is concerned, if you want to find magnification, which is height of image by height of object, it is equal to minus V by U. Magnification is equal to height of image by height of object. It is equal to minus V by U. So this is the relation between magnification and image distance and object distance. So what is magnification? Height of image by height of object. But in case of spherical mirrors, this is equal to minus V by U. V already know which is image distance. U also already know which is object distance. Now when I calculate this magnification, I can get magnification of 2 or magnification of 2.3 or magnification of minus 3.3 or magnification of 0.75 or magnification of minus 0.5. I can get values like this. Now from the value of this magnification, you can conclude some things. So first, I'm taking only the value of magnification. So value of magnification. Remember, value means don't take the sign. For example, what is the value of magnification here? 0.5. What is the value of magnification here? 3.3. Like that. Now, if the value of magnification is greater than 1, you can conclude that image is enlarged image. See, magnification is height of image by height of object. When height of image is more than height of object, then the magnification is greater than 1. So what is m greater than 1? What does the value of magnification greater than 1 signify? That means the image is enlarged. So here you are having an enlarged image. When it is less than 1, obviously it is diminished image. And when it is equal to 1 exactly, then the image is same size as the object. So this is the value of magnification. That is, basing on the value of magnification, you can conclude whether the image is enlarged, diminished, or same size. But the sign of magnification will also tell some things. Sign of magnification. Sign of magnification can be positive, it can be negative. Remember, if it is positive, that means, see, if magnification is equal to height of image by height of object. If it is positive, that means the sign of magnification can be positive or negative. But if it is positive, that means whatever be the sign of height of image, the sign of height of object is also same. That means both are either negative, both are either positive. So when it is positive, I conclude the image is erect, like this. But when it is negative, then the sign of, that means the sign of HA and sign of HO should be different. Then it means the image is inverted. So sign tells you whether the image is inverted or erect, and the value of magnification tells you whether it is enlarged, diminished, or same size. So let me do one thing. Let me give 3 examples to understand this. For example, magnification is equal to minus 0.73. What is the value here? 0.73. So how is the value? Less than 1. So image is diminished. And what is the sign? Sign is negative. Negative means inverted. So image is inverted and diminished. Let me take one more example. Magnification is equal to 4.3. So 4.3. So how is the value? Greater than 1. That means image is enlarged. How is the sign of magnification? Positive. That means image is erect. Let me take one more example. Magnification is equal to minus 1. What is the value of magnification? 1. That means image is same size as the object. How is the sign? Negative. That means image is inverted. And basically, you know that inverted means it will be a real image, and erect means it will be a virtual image. So erect and virtual, they are the nature of images. Diminished, enlarged, same size, these are the sizes of images. So from the value of magnification, that means you can know whether the image has enlarged, diminished, or whether it remains same. And from the sign, you can know whether it is inverted, erect, and from that you can predict the nature of the images. So the formulas which I have given you for magnification and the mirror formula, using this you can solve. That means if at all in exam, if any numerical comes, so you can solve numericals using mirror formula and magnification as far as spherical mirrors is concerned. So that's it for this video. So in this video, I've just confined myself to reflection of light at spherical surfaces. That means basically I've confined myself to reflection. So I will be coming up with another video where we will be discussing that means kind of we will be discussing only the formulas. So in the next video, I will be coming up with another chapter. It may be refraction. So refraction is also one of the most important topic. So till then, keep studying,